When it comes to the ECU configuration process for a turbocharged engine, the process is essentially identical to what we've already looked at for a naturally aspirated engine. There are two minor differences that I'm going to cover over now. And the first of these is the axis scaling or the axis breakpoints that we're going to use for any of our tables, in particular our fuel and ignition table. Let's have a look at our Motec M1 software here, and we can see we have our engine efficiency table. I'm just going to full screen that so we can better see it, and you can see that we have our inlet manifold pressure as our vertical axis. So understandably, for a naturally aspirated engine, the 100 kPa zone that we can see here, this would generally be our maximum value in our fuel or efficiency table. You can see though, in this case, we've extended the axis up to 200 kPa, and this is just going to be done to cover the expected range of whatever boost you're likely to be running. In this case, this particular engine is running around about 170 kPa boost pressure, which is 70 kPa of positive boost. So we're sitting somewhere between the 180 and 160 kPa zones. So you can see that I'm using 20 kPa per step in my load axis, and really the process here is no different to a naturally aspirated engine. We're simply extending the axis out into those positive boost pressure areas, and I'd always recommend extending a little bit beyond the maximum boost pressure we're likely to run. And the reason for this is it's not uncommon, even with really good electronic boost control, to see the boost oscillate or spike a little bit above our set point sometimes. So in this case, I've got the ability to run up to 200 kPa here, which is well above my target of 170 kPa. This just means that if for any reason my boost pressure does exceed my target, I still am going to be running inside my fuel map or efficiency map. Let's cross over to our ignition map and we'll have a look at that as well. So again, I'll just full screen this. And we've essentially got exactly the same thing here. In Motec speak, our load axis is now engine load normalized. However, the values here still relate to manifold absolute pressure and kPa, and we've got exactly the same sort of zoning, although in this instance you can see that I've actually added a zone at 170 kPa right on my boost pressure target, just to give me very accurate control of the ignition timing at the maximum boost pressure I'm expecting to run. So really nothing particularly difficult to cope with there. We just need to extend both our load axis for fuel and ignition out to cover the expected range of boost pressure we're likely to be running. Now, the other configuration change we want to make before we get started with our tuning is to make sure that our boost control system is running the minimum boost pressure that we can achieve, and I refer to this as our wastegate spring pressure. So the minimum boost pressure that a turbocharged engine can achieve is going to be defined by the spring that is fitted to the wastegate, as well as the size of the wastegate, and it even can be influenced by the physical installation of the wastegate, how it comes off the exhaust manifold or the turbocharger. But regardless of all of these aspects, we always want to begin our tuning with the minimum boost pressure we can achieve, and there's two reasons for this. First of all, we want to always start our tuning with a minimum amount of stress and heat being placed on the engine. And understandably, as we increase the boost pressure, we're putting more stress on our engine, it's making more power, and if our air-fuel ratio or our ignition timing is incorrect, as we move into higher boost pressure, this can become a bigger problem. So it's always smart to start with the minimum boost pressure and minimum stress being placed on the engine, and once we've got our tune dialed in at that minimum boost pressure, then we can start increasing our boost pressure and fine-tuning our fuel and ignition as we go. And we'll see this process shortly. Now, the other advantage of beginning with our boost pressure set to minimum is it eliminates our electronic boost control if we're using that, or our pneumatic boost control, and it allows us to confirm that the mechanical boost control system is able to achieve consistent and repeatable boost pressure. So what we really want here is a nice stable flat boost curve. If we're testing and we begin our tuning and we're finding that our boost pressure is either erratic or it's spiking, climbing high at high RPM out of control, or conversely perhaps dropping off and it's not able to meet our boost target, then this is a problem that we need to address. We're not going to probably be able to fix some of these issues with electronic control. And this lets us get a look at our boost control system and make sure it's able to do a good job before we end up wasting a lot of time and effort trying to fix these sorts of problems using electronic control. How we go about disabling our boost control system will depend on the exact system you're running. If you've got a pneumatic boost control valve fitted, then you can either remove that temporarily from the wastegate plumbing for the purposes of our initial tuning, or at least make sure that it is set to its minimum setting. If you're using electronic boost control, you've got a few more options. You could choose to electrically unplug the boost control solenoid to prevent the ECU controlling it. Or in the case of our Motec M1, if we go through to our boost control settings, you can see that I've actually disabled our boost control mode. So this completely turns off our boost control subsystem and leaves the boost control solenoid doing nothing. Conversely, we could also choose to go into our wastegate duty cycle tables and set these all to 0, essentially making sure that the ECU isn't trying to raise the boost by pulsing our wastegate solenoid. However you choose to do it, it's important to just make sure that before we move on and actually start running the car on the dyno, that we have disabled the boost control system. So we're starting with that minimum wastegate boost pressure, wastegate spring pressure, the minimum boost we can achieve. Now we know about our base configuration changes that we need to make in comparison to a naturally aspirated engine. Let's move on and actually look at the tuning process.